guys, this is your favorite YouTube channel A1 Tutors, where we pick questions from past WAEC exams and help you to solve them in order to prepare you for the forthcoming exam so that you can sit independently yourself and do your exam yourself and make it once and for all. So I have two questions for today. The first one said, prove that, if you check, I have this some years ago, like 2 or 3 years ago, prove that VE equals to the square root of 20R. If you look at this question very well, this is the formula for what is called escape velocity in physics. So we are asked to prove it. Now first, what is escape velocity? Escape velocity is defined as the minimum velocity required by an object like satellites, object like rockets, the minimum velocity required by those objects just to escape or leave the gravitational influence or leave the gravitational field. What do I mean? If this is the Earth, for instance, and this is the orbit, if you throw anything and that thing is still within the orbit of the Earth, that thing will automatically fall down. But if you project anything and that thing is able to overcome the power or the influence of this gravity, that thing is able to overcome the influence of the gravity, that thing may tend not to come back again. Those objects that escape the influence of the gravity, they have a particular velocity. So the smallest of the velocity required by an object to escape the influence of the gravity, so that when the object is thrown up, it will not come down, is called what? Escape velocity. Escape velocity is the minimum velocity required by an object just to escape the influence of gravity. So this is the formula. Square root 2GR. Only what is missing here is G, and that is gravity. So the question here says, how do we prove this? So we can prove this from the formula for work done. So recall that solution. So we recall that work done is the same thing as force times what? Times distance. And force, according to the Newton's law of gravity, what is our force? Our force in Newton is Gmm over r squared. This is mathematical representation of Newton's law of gravity that says that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and then inversely proportional to the square of their distance apart. So this is the force. This is the value of force according to Newton in gravity. Now when you put it, we can also recall also that kinetic energy is equals to half mv squared. Kinetic energy is the same thing as what? Work done. So we can say force times distance equals to half mv squared. We can say this. And then replace your force with this. So I have Gmm over r squared, which is our force, now times another distance, and distance in this regard is the same thing as what? R, because I told you distance apart we use letter R. According to Newton, every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of their distance, which means this R is meant for what? Distance. So that is what I've done here. Everything equals to half mv squared. So here we try to make v the subject of the formula. So first let's go for this and this. So when one of the distance there cancel the other there, I'll be having half mv squared equals to, then here I have left Gmm over r. One of the r is already cancelled. So we can divide both sides by m over 2. So divide both sides by m over 2 because I want to make v the subject of the formula. So m over 2. So when you divide both sides by m over 2, I'll be having v is equals to, so v squared is equals to gm over r times here become 2 over m. Why? I am dividing both sides by m over 2. So when you say here divided by m over 2, when you change that division symbol to multiplication, 2 comes up and then m goes down. Therefore, I am having v squared is equals to 2. So m go for 1 m here. So I am having 2gm over what? R. So v squared is equals to 2 times gm, that is 2gm over what? R. And finally, I'll be having ordinary v to be square root of 2gm all over what? R. Square root of 2gm over R. Don't forget what you are trying to prove is escape velocity, but yet you have not gotten this. Now we also recall that there is a relationship between small g, which is gravity, and capital G, which is gravitational constant. This is small g, acceleration due to gravity, and this is capital G, gravitational constant. So there is a difference between both of them, and the difference is that small g is equals to capital G times m over r squared. So we came across this from the relationship. I just don't want to bring it out. This is where I came across this. So if I want to get the relationship between this small g and capital G, we can use formula for force. Our force is mass times acceleration, and our force also is gm over what? R squared. Now make this thing the subject of formula, meaning we are dividing both sides by what? M. So small g is equals to gm over r squared times, because I'm dividing by m, so it becomes 1 over what? M. So this go for d. So small g is equals to gm over r squared. So I came about this from formula for what? Force. So we can calculate force using mass times acceleration, and in Newton we calculate force using gmm over r squared. We have it on the board. So I just try to make small g the subject of the formula. Now in here I have capital G. So let me make capital G the subject of the formula here and then introduce it here. So I'll be having escape velocity is equals, okay, let us make capital G the subject of the formula now. By the time you make capital G the subject of the formula, I'll be having capital G is equals to gr squared over what? Over m. I have made this capital G the subject of the formula. Now we can substitute here. So our escape velocity now is going to be square root of 2 times our capital G is gr squared over what? Over m. Then times, don't forget your what? Don't forget your n. Then times 1 over okay, 1 over what? 1 over r. So what do I mean? This is 2. Then instead of writing g, I've written gr squared over what? M. Then times what? M. But everything divided by r. But when you change this division symbol to multiplication, it becomes everything times 1 over r. I'm very sure you understand this. So this go for this now. Then r will go for one of the r here. Now I have my escape velocity equals to 2. Then I have here, because m has gone, r has killed one of the r here, so I have 2. So square root of, I have 2 left, then I have g, then I have what? R. So I have r. So since r is equals to this, then we can have it as our escape velocity is equals to, square root of 2, then g, then r. That is exactly what we are asked to do. Now, but here we don't have g. What we have here is 0. Now we are going to recall that g is the same thing as 10. So recall that g is the same thing as 10. So recall, so let's have it here. Recall, okay? Recall that g is equals to 10. Now we can have it as 2 times 10 now times what? r, and that is 2. So that is exactly how we got it. So I have it as square root of 2 since g is equals to 10 meter per second square. So we have been able to come to the end of that problem. So let us go over it again. We have escape velocity, and it was obtained from the formula for work done. So I have work done as force times distance. Another work done is half mv square, which is kinetic energy. Energy is energy, whether kinetic, whether potential, whether work done. And that is all of them are measured in joule. So I can say our work done now, since they are all measured in joule, our work done is equals to half mv square. And this is another formula for work done, force times, yes, is correct. Our work done, which is force times distance is equals to half mv squared. Then I have told you to recall force as gmm over r squared. Our distance is also r. So by the time you follow the analysis, then this is what we arrive